7. Jullian, Escubil, Agno, Pizzaro, Tiara, Roldan, and we are here to talk about Charles' Law. Jacques Alexander Caesar Charles was born on November 12, 1746. He was a French inventor, scientist, mathematician, and balloonist. Charles wrote almost nothing about the mathematics, entering on May 12, 1785. He was sometimes called Charles the Geometer. Charles and the Robert brothers launched the world's first unmanned hydrogen-filled gas balloon in August 1783. Then in December 1783, Charles and his co-pilot Nicolas Louis Robert ascended to a height of about 1,800 feet in a manned gas balloon. Their pioneering use of hydrogen for lift led to this type of balloon being named a Charles.
Charles' law represents the scientific property of expansion, which means the action of becoming larger or more extensive. This is complete opposite with the Boyle's law, which represents the scientific property of compression. Now, we'll move on to the concept of Charles' law. Charles' law states that the volume and temperature are directly proportional and it is not affected by the pressure, which means if temperature goes up, so is volume, and vice versa. And if volume goes down, so is temperature. Now, let's move on to the formula of Charles' law. V1 divided by T1 is equal to V2 divided by T2. V is representing volume and T is representing temperature. Now, V1 and T1 represents the temperature before the change, and V2 and T2 represents the temperature after the change. Now, before we proceed to the experiment, I would like to present you the materials that we're going to need. First, we're going to need a boiling water, 2 balloons, one is slightly larger, I'll explain later, a Pyrex container, and a cover. What's going on in those balloons, and after that I'm gonna show you some sample formula on how to solve Charles' law problems.
Charles' gas law states that when a fixed amount or mass of an ideal gas is kept at a constant pressure and in a closed system, then its temperature and volume are directly proportional. What this means is, when temperature increases, volume increases, or as temperature decreases, volume decreases. As we mentioned in our last episode, an ideal gas is a theoretical gas composed of a set of randomly moving, non-interacting particles. Under normal conditions, many gases such as oxygen, hydrogen, and some heavier gases like carbon dioxide will behave like an ideal gas. This means they follow the laws of gases such as Charles' law. In our experiment, our balloon is filled with gaseous air molecules. When the balloon is placed in the beaker with boiling water, the energy from the higher temperature water and steam molecules transfer to the lower temperature air molecules inside our balloon, exciting them. When the air molecules in our balloon are excited by raising their temperature, they spread further and further apart, increasing the volume of space they take up. The higher the temperature or the more energy the air molecules get, the larger our balloon will grow, or in other words, the greater the volume of space our gas will take up. If we remove our balloon from the hot water, the air molecules inside our balloon will gradually lose the energy they've been given, dropping back to room temperature, causing the balloon to shrink in volume back to its original size. In the second portion of our experiment, we place our balloon in a freezer, which causes a transfer of energy in the form of heat from the warmer air molecules inside our balloon into the cold freezer. As the energy is removed from our air molecules, they slow down, drop in temperature, and get closer and closer together, decreasing the volume of space they take up. The colder the air molecules get, the closer together they will be. If the temperature of a gas is lowered low enough, it will go through a change in state from a gas into a liquid. When we remove our balloon from the freezer, the air molecules inside will gradually gain extra energy from the air in the environment, raising its temperature, causing the balloon to increase in volume back to its original.
In this video that I'm about to show you is, I'm going to solve some sample problems. So, let's get started. In the given, a 3.5 liter flexible container holds a gas at 250 Kelvin. What will be the new volume if the temperature is increased to 400 Kelvin? So, let's first identify the given. We have the volume, we have the first Kelvin, and next, what is asking what will be the new volume after we increase the temperature by 400 Kelvin. Now, this is how you're gonna solve this. You cancel out L and K, and when you cross multiply. So 250 Kelvin is equal to 400 times 3.5. Which gives us about 1,400. Now we're gonna divide that by 250 Kelvin. Now let's disregard the Kelvin first. So we can divide 250 by 1,400. So which leaves us to 5.6 liters. So the new volume is 5.6 liters. So if you want to check if this is correct, all you gotta do is cross multiply with the new variables. So if we cross multiply 400 Kelvin times 3.5, we get 1,400. So if we cross multiply 250 by 5.6, that also gives us 1,400.